Hey Ebony, so I was looking at this one and I think it's the very last step that you're having troubles. So that was our original problem. I moved the negative 2i squared over because we want to get equal to 0, and I much prefer having that a term be a positive number, so much easier. Here I chunked it into the quadratic and I got to here, and I bet we have the same answer up to this next step based on what you wrote. So with that 40 right there, we would think of that as a 4 times a 10, because 4 is a perfect square, and we would bring that out front, and that would be 2 square root 10 over 4. And you got 1 plus or minus 2 square root 10. Yeah, so what I think you did was right here at this step, you looked at those 4's and went, 4 over 4 is 1. That is true, except that this 4 belongs just as much to this 2 over 10, or 2 root 10, as it does to the 4. So let me show you the slightly longer way to think of this, and I'll show you a shorter way in a second. If I think of what is common in all of these and I try to factor it out front, I could factor a 2 out of this numerator, 2 plus or minus root 10. Because if I go 2 times 2, there's my 4, and 2 times root 10, there's my root 10. And then downstairs, I'm going to think of that 4 as a 2 times a 2, and then I can cancel. And right there is your answer. I wouldn't suggest doing it that way, but that's why that math works. You can't cancel unless you can factor, and then there's a common factor. So in this case, there's a common factor of 2 in both the numerator and denominator, so I'm reducing that. But an easier way of looking at it, just kind of practically speaking, is you're going to look at all the numbers not under the root. You can kind of think of that root 10 just like as a variable, like an x or something, and you're going to see what you can do with the coefficients. So then 4, 2, and 4, then it's pretty easy to see that 2 is the number that goes into all of those. So 2 goes into 4 twice, 2 goes into 2 once, and 2 goes into 4 twice again. And then if you look, there's the 2 plus or minus 1 root 10, which we'll just write as root 10 over 2. So it's the same thing I have here, but it's a lot easier than thinking of all the factoring. Just along those lines, let me make up one here. Let's say I had 15 plus or minus 9 root 7 over 21. So if I was trying to reduce this one, I would look at it and go, okay, 15, 9, and 21, there's some 3's going on there. So 3 would go into 15 5 times, 3 would go into 9 3 times, 3 would go into 21 7 times. And so I'd have 5 plus or minus 3 root 7 over 7. So I think that is easier than the factoring version. It's the exact same math. This is just a little bit cleaner for at least my brain. Hopefully that helps. I'll check and see what these next ones are doing. Hopefully it's just that same spot, and then you fix up that one thing and it fixes all of them. So let me take a look at the next one here, and I'll get back.